Surprise! Hi, this is ARP, and this is a surprise. So instead of typing long text and making you feel bored, so instead of making this a video, actually we are going to deal about the imaginary numbers, and it's not a good way to type things and make you more confused about the imaginary numbers. So okay, what do you have any idea about imaginary numbers? So, do you think that people really understood imaginary numbers around that? So, just take a snap of, just take some, we have some videos. Just go through it and understand that people, no one ever understood imaginary numbers on their own, and there is no such thing as imaginary numbers, and people have created some ideas, but they have just round off. But no one really had seen any imaginary number and haven't gone in depth through it, but they are using the idea to get into some real stuff.
I can absolutely see how you does your head in. As a first-year undergraduate, as a second-year undergraduate, as a third-year undergraduate, and as a professor of physics, it does my head in. So it's it's a very tricky concept.
But can you get your head around the idea of an imaginary number?
In truth, no. It's a device. It's only a mathematical convenience. It's a way to help us to use the equations to get a prediction.
Hi, hope you have seen the videos. And do you think these people are ordinary people? They are greatest professors in physics who have been teaching physics for a long time. And these guys have been the greatest inspirers for me for making this kind of video stuff. And if you want to check out their works, just get into the 60 symbols and check out their videos on the YouTube. They're awesome, but extremely awesome videos. They're giving such a nice kind of insights on each and every physics concepts. So even these people are telling that they can't get their head around the imaginary numbers. So it's just don't get afraid about the imaginary numbers. This is a really complicated stuff what we are dealing with. This is right. So again, it's not a much complicated kind of stuff. And once we have developed an intuition among it, it's the easiest of all, as an obvious thing. Normally, if you say something is strange, and until it gets pretty, used, if you are getting much used to it, then it becomes obvious, right? So when you are getting much used with the imaginary numbers, then it becomes pretty obvious. Then you don't need to get scared about these imaginary numbers. So what are these imaginary numbers really tells us? So before getting into what imaginary numbers really are, we have already developed some intuition among the negative numbers, right? In our previous post. I hope you have read those posts. Actually, what a negative number really means is, whenever if you are saying that a 50, then if it gets flipped over, that means just the opposite, then you get a negative number. So suppose if you are traveling in the north direction and some person is asking how much faster you are traveling in the south, and if you are traveling towards north in the 50 km/h speed, so what would you be saying? You are traveling towards north, and he is asking which direction, how much speed you are traveling towards. So you can say -50. It's a similar kind of idea of what imaginary numbers are. Instead of flipping over, it's just an idea of rotation. Just have that in mind. So as we slowly progress towards imaginary numbers, it will make sense. So okay. When do we go for square of numbers? Let us say we take 16 as a good square number, which is the square of a 4. So if you want to end up in 16, what you are about to do is you take 1, multiply it with a 4, and multiply it again with the 4, so it end up in 16. Similarly, if take any number x, you want to end up in the square of the x, then you just take 1, multiply it with the x, and multiply it again with the x, you end up in x square. A similar kind of idea. So the I, whatever we are calling the I, the imaginary number, or sometimes we used to call J in terms of electrical symbols, because the I is a symbol for current. We are probably running out of symbols, so we are having some confusions there. I just don't mind. Currently, we will just stick on with the symbol I. So what we are having right now is the imaginary number. So normally you might have heard that imaginary I is a root of -1. So if you want to get into the -1, but it has to be a square of a number, right? So whenever you are trying to square something, you get into the positive zone only. So whenever you square 1, you get into 1. And unfortunately, if you square -1, you again get into the -1. So how to get into the negative zone? So instead of flipping over, and normally what flip so means is, if you are having 1 or 4, if you want to get into -4, just multiply it with a -1. So you get into the negative zone. So it's just a single operation. But a square is, as I have mentioned, you start off with the 1, you just multiply it with that number and multiply it again with the number, so that you just end up in the -1. So you just start up with the 1, multiply it with the number, and multiply the number again, so that you will end up in a -1. But it has to take up in 2 steps instead of multiplying as a simple -1, so that you will end up in a -1. So for imaginary root, for taking a root, you have to do it in 2 steps. So a number, what can you do in 2 steps so as to get from +1 to the -1? In real world, we may think that it is not possible, but you have to create some ideas about how to do it. So if you take a rotation into the region, then you could do it, right? So if you start up with a 1, you just rotate it 90 degrees onto the top, and then rotate it again onto the again 90 degrees, then you end up into the negative direction. So what does this thing mean? This is the real I. So this is the imaginary number. So this is I. So whenever you multiply 1 with an I, you just end up in the in the imaginary axis. You multiply it again with an I, you end up in the negative axis. To get some more fun, so instead of even being in the negative -1, you just multiply it again with I, so that you end up in the negative imaginary axis. Catch the pattern that you are going in circles by 90 and 90 degrees. So you multiply the -I again with an I, you just end up in a positive direction where you have started earlier. So this is a kind of an intuition that you have to develop to understand the imaginary numbers. Again, these things actually solves a lot of problems in the real world. If you think what does this thing really means, it just takes actually we used to have the real numbers in a single dimension, even in one directional. So after the negative numbers have been introduced, it has gone infinitely onto the both sides, creating a one-dimensional number. So what imaginary number really means, it takes us into the second dimension. So do you really think there is a third dimension? Yes, there is. Actually, in gaming, people used to have to make rotation. They used to get into the fourth dimension. So this is a kind of crazy stuff. We just have them in mind that people used to do this, but for understanding and certain concepts, we just stick on with the two-dimensional area, and we don't confuse ourselves more. So if you are really crazy about this, just Google it on yourself. So we start up with an 1, you just end up with an I, and you get into the minus axis, so that you have a two-dimensional number plane. So actually, in real world, how we match this thing? So as I had said, if you are traveling towards north and at a 50 km/h, so if some people ask how much faster you are traveling towards south, you could say -50. If some people ask how much faster you are traveling towards the east, so how you correlate these things? Let us say, if people ask how much faster you are traveling towards the west, and if you are traveling towards 50 km in the north, you could say I am traveling at 50i. That's the real idea. So and does the imaginary number stop with this? So it's not. So actually, whatever I was telling is just about one-dimensional, but it's rotated again. So to us to have a complete two-dimensional view, what we need to do is we just don't stick on to either moving north or only in south or in the west or in the east. So what we'll be doing is we'll be traveling all over in the geographic plane. You can travel northwest, southeast, or northwest, and all the directions, and even it has to be not exactly 45 degrees in the northwest direction. You can travel at any degrees, right, you want. So how these numbers can be represented? These numbers are represented by complex numbers. So it is nothing but a combination of you are having some real value, that is some with reference to the northern direction, and with reference to the western direction you are traveling in the northwest, right? So if you are standing at some point, or if you are traveling towards some direction at some speed, it will be having some coordinates, we have some stuff in the physics as coordinate. That means it has some components in the north, and as well as it has some component in the west, even if you are traveling in this so how much it extends is that gives you that if you are having some 3 in the real and 4 in the imaginary, then you are traveling at a 3 plus 4i speed. So that's the basic idea behind the complex numbers. Hope you have enjoyed it, and thanks for watching.